This is question 31 from section 1 of the 2018 ENGAA paper. This question asks us to find a number of solutions of this equation, 2 sine cubed theta equal to sine theta, for theta in minus pi over 2 to pi inclusive. You may have noticed that this is a cubic in sine theta. So if we let y equal sine theta and look at this, 2y cubed is equal to y, we can find all the possible values of sine theta we'll have to look at for theta in this range. So if 2y cubed equals y, we've got the nice easy solution of y equals 0, or we've got the solution of 2y squared is equal to 1 by dividing through this by y. And this goes to y squared equals a half, dividing through by 2, and gives the solutions y equals plus minus 1 over root 2. So this generates all of these, because y equals sine theta, so sine theta equal 0, sine theta equal 1 over root 2, and sine theta equals minus 1 over root 2. Now none of these can we instantly reject, because all of these values are between minus 1 and 1. And so we know the sine curve definitely attains these values. So we've got to look at each one of them individually. So here we have our sine curve from minus pi over 2 to pi in solid red line. And we essentially want to move this blue line around because this corresponds to either of these as we move it up and down, see how many intersections we have. So we'll start with sine theta equals 0. So that case is essentially when this happened. And you see here, we have 2 intersections. We have 2 because pi is in the range. And so this corresponds to 2 solutions. Now, for the sine theta equals 1 over root 2 case, we do a similar thing. So take this line and move it down to 1 over root 2. And we see we have 2 solutions. Here and here, 2 intersections. So let's put that on. Now for our final case, sine theta equals minus 1 over root 2. So let's do exactly the same thing, but we get a slightly different result here. So when we move this blue line down, it's roughly here. So we certainly intersect it once here, but never over here between 0 and pi. So we get 1 solution here. So counting up our solutions, we see we have 5 in total, and this corresponds to answer D. In the multiple choice, so our answer is D.